Hey, welcome back. In this session, we will talk about geometry, part C. We will start with similar triangles. A quick review of similar triangles we have talked about in part B. We will mainly see similar triangles in two scenarios. One is parallel cases. In these two cases, similar triangles are formed. The small triangle is similar to the big triangle. The other scenario is right triangles. In this case, three triangle, the two small one, and the original big triangle. Those three triangles are similar triangles. Let's see some real questions. This is 2016 problem 22. Let's pause the video and think about it. Okay, let's come back. So here we have a rectangle is 3 times 4. So this is 4 and this is 1, 1, 1. The area of the bat wings shaded area is. So we just need to find out one area. And so here we see these two lines are parallel. So these two triangles, they are similar triangles. And their ratio is 1 to 3. Then we know the ratio is 1 to 3. And if we can find the area of this small triangle, we are done. So here we can do a height. We need to find this height. So the small height and the big height, the ratio is 1 to 3 because the total is 4. So here, actually, the small height is 1, the big height is 3. Now that the small triangle will be 1 times 1 divided by 2, 0.5. And let me use a different color. And we know this triangle is 1 times 4 divided by 2. That is 2. So one bat win will be 2 minus 0.5, 1.5. So each bat win is 1.5. So the 2 bat wins is 3. Okay, let's move on with the next one. This is 2016 problem 25. Let's pause the video and see if you can get it. Okay, let's take a look. A semicircle is inscribed. Inscribed means it's just touched with the side of the triangle. So the triangle is base 16 and height 15. So how about we do a height? And we know that because it's an isosceles, the height will be the middle point. And because it's symmetric, the height will also be the center of the circle. So it's 8 and 8. And the height is 15. So first, probably we can first find this side by Pythagorean. This is a common theme Pythagorean triple. That is 289 square root 17. Okay, so we first, by Pythagorean, we get one side of the triangle. Here, the next. What is the radius of the semicircle? So we are looking for the radius. It seems we need to connect the radius with the touching point. This is called tangent line, tangent. So the property of tangent is that we have a circle and then we have a line tangent to this circle. So the tangent line only touch one point with the circle. And if you do a line segment from the center to the tangent point, it will be perpendicular. This is the property of tangent line. So here we have 1, 2, the original one, 3 similar triangles, right? Because obviously we need to use similar triangle to find the radians. How can we do that? Let me use a different color. So here we can use this triangle, similar with the original big one. So let me redraw it. This one is R, and we only know the diagonal is 15. And the original big triangle is 8, 15 now is the height. This is 17. They are similar with each other. So we can make a ratio equation like 15 over 17. This is a ratio is equal to R over 8. This is an algebra equation, so we can solve it by cross multiplication. We get 120 is 17 times R. So R is 120 divided by 17. So you can see Part C questions, sometimes it will need you to combine your skill of geometry and algebra. That's why the questions tend to be complex. So you need to have some tools in your toolbox and pick a right time to use it. Okay, let's see the last one. This is 2017 problem 22. Again, let's pause the video. Okay, let's come back. So here, again, a semicircle is inscribed in the triangle as shown. So this is the tangent line. So whenever we see a tangent line, normally we need to find the center and connect it. It will be a right triangle. And then it forms a similar triangle. The small one is similar to the original ABC. So what's the radius of semicircle? Let's put R. That's what we are looking for. Okay, so first, obviously, we should use Pythagorean. 5 square, 12 square. This is a very common Pythagorean triple, right? It's 169 square root, so 13. We find AB is 13. Now let's use a similar triangle. Let me take it out. Similar triangle AO, let's say this is D, AOD. So this is, we only know this is R. And this is R as well, similar to the big triangle that is 13, 5, 12. So what else do we have? Let's see. Let me use a different color. So let's see this. This everything is the same, so this must be 5. And this is R, this is R. They are totally symmetric, so this is 5, which means AD is 8. Oh, nice. We find something. This is 8. So now we can do the similar triangle again. The ratio 8 over 12, that's the ratio, is equal to R over 5. Again, cross multiplication. 40 is equal to 12R. So R is 40 over 12. So that is same as 10 over 3. We get it. So this one is similar to the previous one. So it tested some skill of tangent line and also similar triangles. Again, it's a combination of algebra and geometry. Okay, I hope you enjoyed this video and I'll see you in the next lecture.